welcome. Hi, April. Thanks for joining us on the stage. Let me just pull up my beautiful slide showing your name, which is not actually your name. Your name is April Staines, not April Storm, but that's okay. We know that. I'm really pleased to introduce April with her presentation, Sci Fi Props and Rockets, to Rockets, My 3D Printing Journey. I've known April for a few years now through our time at through the Melbourne chapter, and April is currently our Melbourne chapter ambassador. So it's always really great to hear from our ambassadors and get to know a little bit more about them. April has a really quite exceptional history and knowledge of 3D printing. She's been able to essentially start a print farm in her own backyard, which is a female-led, owned, founded business. I'm really excited to hear more about what you've got to say, April. April has also been very generous in giving us some site tours, some virtual site tours of her her print farm in her shed. And I say shed, but it's like more than that. It's much more. So anyway, thank you, April. I'll let you just share your screen if you would like.
Okay.
Awesome. Looks great.
Hi. Hi, everyone. I'm April Staines. Look, I've got a lot of material to get through, so I'm going to probably get through these slides pretty quick. If there's anything that you need to, ask me about, maybe just pop it in the Q&A in the chat and I'll sort of answer it later. Just a bit about myself. I consider myself to be a space cadet. In 2011, introduced about 2009. I made my own 3D printer back then. I like to make and create and solve problems and puzzles. And tech's always been the thing that has enabled me to do this. I've always worked in tech, but it was probably more so in the software side earlier on. That was where my career sort of started. And I really like to make and I get to make cool stuff, which is the thing that really sort of I've got a passion for. I'm also a co-founder of Girl Geek Academy, which is an organization set up to increase the number of women in tech. I am the AM engineer for Jerime Enterprise Space, which is a space startup. I'm the principal engineer at National Australia Bank, which is my current day job. I'm basically, kind of the chief in the engineering area, software engineer, that is. Also the regional commander for Oceania for the Mandalorian Mercs costume. Before the whole Mandalorian show came out, I've been with that club for almost as long as I've known 3D printing. So the mission for Girl Geek Academy is to teach 1 million women technical skills by 2025, and we're well on the way to do that. I think we may have already. This is the group that founded Girl Geek Academy. That's basically the team. I am the chief maker. I like to make things. Where did it all started? Well, I think my journey started with this little machine, a MakerBot Cupcake CNC, which was the forerunner to the Thingo-matic. I'm not sure if anyone's actually seen one of these. We're a Kickstarter. It was one of the first times I'd even heard about Kickstarter. And this thing was tiny, but basically with it, we're able to print parts to build the next printer. The RepRap revolution started. I had a theme. I made all my printers pink, just to annoy everyone, I think. But this one was more of a fuchsia color than a pink. That was a Mendel Max, and the one before that was basically one of the very early Pruzas, which was a terrible machine if you ever had to. So all these bolts and things are all very loose. That was printed on the MakerBot on the Cupcake CNC, or most of the parts were. So they were constrained to a certain size. But it was the first printer I started using to make props with. Prop making workshop. My workshop has kind of changed when I started. When I sort of really got serious was about 2013. You can see in the background, those Mendel Maxes that I made myself. We couldn't buy a lot of parts. You had to make them. The hot ends were actually a resistor that was shorted out and got hot and was shoved in a copper kind of, bit of metal with a bolt on it and drill a hole through the bolt to make the nozzle. It was very, very primitive, but it worked. And those are some of the things I'm holding in Skinny April for 2013. There's on the right-hand side, there's Fat April, current state. And just the background in my workshops, there are a lot more advanced printers. They're my high temp printers that I print primarily in ABS. So I need something that are enclosed and so on. So the printers I do use, I actually have a lot more than this. I have 6 large FDMs, large FDM printers, 8 sort of medium size printers, and I've got 4 DLPs, resin printers basically, which I use for that sort of work. This was one of the first prints, and I always show it because it's just historical. This is the first print I ever did on the Mendel Max, and it was a scan of my head. So, and those sort of aberrations you see in the print itself, that's not in the scan. The printer was adding it then. It was a feature. So, things have improved. I've actually printed off some lamps in my house that I actually use, and they're quite decorative. They're 3D printed. And every Halloween, I create a new 3D printing thing, except this year I was printing Audrey from Little Shop of Horrors, but I never got it done. It was so big. You underestimate the much plastic it used. So I never got it done in time, but that's, from Lord of the Rings. Anyway, 3D printing for FDM and FFF plastics for prop making. It's all about the material sometimes. PLA is dimensionally stable compared to ABS. It's all easier to print with, and a lot of people are using PLA. PLA has probably got a little bit better since I wrote this. But I tend to use ABS because the things need to have a lot more structural integrity. Plus, you can weld them a lot easier than PLA. PLA, you've got to use glue, and you've got to keep on buying glue. PETG is a new one now. People are using PETG. I use PETG a fair bit. It's easier to print with than ABS. Doesn't need the heat. It's also supposedly recyclable, but I think that's questionable. And obviously, we've got a whole lot of hybrid plastics, which you probably all know about: PLA plus, ABS plus, PPLA. God knows, they can mix anything. PPLA is actually a mixture between PETG and PLA, but I'm not sure if that's the technical name or what the product is just sold as. There's a whole bunch of flexibles in FDM. I typically use TPU. TPE is just a bit too hard to print with, and you need special hot ends. And then there's all sorts of infused plastics, and hybrids like carbon fiber, woods, metals, and so on. I tend to avoid those because they're just generally more work. So, I tend to finish my products. I have all these different things I do. It's not just if I'm making a prop, it can't just be the 3D print. You've got to do stuff to it. So, there's things like using a higher resolution to print with, which means it takes a lot longer. The spray filler putty is something I always use to basically hide print lines. Acetone and acetone vapor can be used on ABS. They used to, but it's kind of dangerous, so don't do it. There's sanding, it's called smooth on, and so on. Multi-part, designing things so they can be sanded, so you can actually. And you need to use power to make big things. It just takes too long. The need for investing in good safety equipment. So decent respirators and eye protection, particularly if you're doing things like sanding. And you never know. Supports and things can fly off and go in your eyes all the time. So I often cut myself. This is a print from one of the first times I printed again, Skinny April in the background. Quite a while ago, multi-part, that's the Alien pulse rifle. It was apparently the first time that prop had ever been 3D printed in the world. So there's a bit of prosperity there, a photo of a prop. I haven't made much bigger props. So this is, it's not actually R2D2, it's R2KT. And it's basically for doing charity collections for, and you can look up R2KT online, and you can see all the sort of things you can. There's a whole chapter about this particular droid. But basically, I made one. It's for raising funds for charity, kids charities in particular. And it's basically entirely made out of PETG. So you can see that it was made out of multiple parts, and I sort of welded them together. I use heat or thermal welding for this rather than glues. It's a lot stronger. PETG is actually really hard to glue, I find. Other props, this is BB-8, which I think you can probably see in the background still. BB-8 is probably one of my favorite droids. It was printed in multi-parts. It's all actually ABS. It was at the premiere of The Force Awakens in Melbourne. I had to buy it a ticket because they considered it a person. So it sat in the seat next to me. And there's the photo from the midnight premiere screening of The Force Awakens. Some other things. I just thought I'd go through a whole lot of stuff. People always like to see all the things. Things like helmets and armor and lightsabers and blasters and so on. Most of these I've designed myself, like the Princess Leia blaster. It's something I actually designed because at one point you couldn't buy it. You just couldn't get it in this country. It's just hard. So it was really easy to 3D print. It was one of the first 3D models I actually produced, and then I shared them online and put them on Thingiverse, and you can just go and download it today, actually. And then, we started getting more complicated with our 3D prints. So this is a 3D printed prop. It's a gauntlet that goes on your hand. And I was like, well, it's a pain in the neck to try and get this on your hand. So how do I do it? So I actually put a hinge into it. And then I decided, well, it probably just needs a clip. And funnily enough, this became the standard for this kind of, prop, particularly with the costumers and the reenactors who like to do Mandalorian cosplay. So this is a very popular file that I think if you find a Mandalorian cosplayer out there at a Comic-Con, chances are they've got this gauntlet because there are thousands and thousands of them out there now. And it's all about the design. So making sure you have a good design that can be easily printed. So this is a helmet, and it bears the Australian name of the drop bear. I had to name it and give it a good name. The files are available free to download, so God knows how many of these helmets are out there. I know they're very popular in Australia because it has air conditioning. Well, sort of. It has fans. So over here, there's a little space that's been designed into the model so you can embed a fan, and it has ducts, little air ducts, so that it blows cool air over your face that is sucked from outside the helmet, which means, the die-hard cosplayer can wear this for much, much longer than your traditional helmet. It also can be printed in parts, so the dome, and so you don't need to use as many supports. It's quite easy to print, and it was designed so I could print in ABS, so it's quite tough. And can withstand Australian conditions, particularly if you leave it in the hot sun and the thing will melt. PLA has that problem, as people probably know. Leave it in a hot car and it's putty by the end of the day. So, here's some examples. That's actually me with my BB-8. Again, I've put on a bit of weight from there. I'm sure if I quite fit into that costume anymore, but we'll find out soon enough. That's some sort of stuff. Mandalorian costuming is all about getting it gritty. Getting that gritty sort of authentic look is actually, you've got to make it nice and shiny first, and then you've got to throw it on the ground and scratch it up. And you need to put layers of paint and so on and sort of dirty it up. But that's an art form in itself. So there's a whole bunch of stuff. I've lost count of how much of this stuff I've actually made, but this is just one of the photos I could find. I'm not sure if you've all seen The Mandalorian. This has created a again in the Mandalorian culture within the Star Wars universe. So much so that Disney approached us, and as I mentioned before, I represent the costume club. I'm sort of the original commander, and Disney actually got us to do their promo when they launched it it was actually in Victoria. It was at Southern Cross Station. So and that's me in my thing. You can see I'm a little bit wider than previously. This is actually at the Disney offices, inspiring the staff on how to use their computer systems. And That's actually a photo of all of us who came along that day shoved in the elevator. So when that elevator opened, all these mercs just burst out. It was actually a lot of fun. Again, most of the stuff in that photo is all 3D printed, and yeah, a good deal of it's come from my printer, but you know, other people's printers, and then we've shared files and collaborated that way. It's very exciting. It's a lot of fun. I really enjoy it. Just a bit of you know, this was kind of was that. I sort of made this video of all our you know, nerds hanging out, being nerds. We enjoy to be nerds. So this actually goes on for a few minutes. I'm just not gonna show the entire thing, but again, the majority of that stuff is 3D printed. So okay, some more examples. I've been doing this for a while. I've always liked the original trilogy and the pilots. I have a big thing for pilots. So I have a lot of these helmets. I've 3D printed all of them. Again, it's, you know, I enjoy getting in there. I definitely don't fit in that flight suit anymore, but I will work towards it. I'll get there at some point. Again, the droids. The interesting thing is, while the snow speeder behind me is not actually 3D printed in its entirety, because it's quite large, it doesn't even fit on a trailer. It has to be taken apart because it won't fit down the road. It's too big. The design was actually done using the same software, using SketchUp. I designed it in SketchUp. We 3D printed a model, and then we worked out how to make it out of MDF and wood and plywood and so on. So 3D printing was involved in it, but you know, all we did with the 3D printing was print the dashboard inside, which unfortunately never got installed. I think the guy lost interest who you know, he's got it at his house. So I've just gone and I keep on nerding it up because I've got to take it to the next level. I got, I don't know, maybe it's midlife crisis. I bought a car, you know, sports car, and it's the Mandalorian Merc, by the way. So that's what it's called. And we've so I'm still a work in progress. I'm kitting it out. I've got R2-D2 on the back now. It'll have like blasters and things on the sides and little fins and so on. But it's just, again, 3D printing has been the thing that enables it. Having a lot of fun. It's basically a very pleasurable exercise. Every May the 4th, we get out and drive around. And yes, I can actually see very well out of the helmet, and I have driven around. The problem is it does create a hazard for other cars because people tend to freak out and try and take photos of you while they drive. So it can be dangerous, not for you, but for everyone else. Okay, so perhaps this slide is out of place, but it's all about making stuff, and we're talking about crafts. So I also like doing crafts, right? Other things, not just the big props, but the small things as well, because why not, right? I always like doing that. And again, we always try and augment the 3D print. So it's not just the 3D print, but it's other things that we do as part of that, as part of the making process. And it's things like jewelry, war game figures, and all that sort of stuff. Again, it's sort of the other spectrum, but it's still kind of, you know, part of the ecosystem. And you know, it's everything from functional items, ornamental displays, you know, jewelry and those sort of things. And it's also, you know, what are you actually outputting? Is it the final product, or is it actually part of some other chain of production, right? So is it a mold, or is it something else? And I'll sort of get to what I mean by that. Okay, so this is an example of me nerding it up with my love for Mandalorian culture and Star Wars. This was done years ago, by the way, before that show came out. And this is a good way to get sued by 2 franchises, because I mixed Hello Kitty and Boba Fett to create Hello Boba. I think that's what you call it. But I wasn't content with just printing them in plastic. So, you know, I actually sort of designed something that could be printed cheaply because it doesn't have a lot of physical material. And it was a thing that I was selling at one point. I don't do it anymore. It's too much hassle. But this is 3D printed brass, and it's been gold plated. Okay, now, you probably all know about, I left the slide in there here. I sort of pruned off the 101 slides mostly, but SLA or DLP, you know, basically, you know, using light-sensitive resin to build physical models. It's become a thing. It's cheap, it's accessible, it's quick. but it has some limitations. So basically, and it's more expensive, right? So if you're trying to do an R2D2 full scale, it's going to use a lot of resin. It's probably going to be really heavy. But for little things like, you know, little miniatures and those sort of things, it's actually pretty good. And one of the things I really like is the translucent or the clear resin is clear. It's not like FDM where you've got the print lines and it diffuses light. So you can make lenses, which are fantastic for droids because they need hollow projector lenses and they have to be a specific size. And we used to get them out of photocopiers, but it's much easier. You just print them, and they actually work, which is really cool. Yeah, and then that's like one of my favorite sort of figurines. It's a it's actually Wonder Woman, so a former Wonder Woman, and just showing you the detail that you get with this is actually quite a large model. It's probably about 40 centimeters tall, and you can sort of see the detail here that you can get from a DLP printer. It's just it's very, very, very good detail. Incredibly cheap machines and very fast. So yeah. Okay, and then I've started using DLP for gauntlets, right? Just because it's so much easier to finish. You don't have to sort of sand them and get rid of all the print lines. So things like gauntlets, I've got my DLP printers are actually big enough now to fit in gauntlets on them. So although they're not quite as strong, they're acceptable. It's an acceptable compromise for the quality of the detail. I think, again, they're still quite functional, except you do have to sort of take other considerations in. They're not quite as drop resistant. And yeah, they tend not to be as good with heat. But then, yeah, it's a good compromise for the quality. Okay, so if you want to make other stuff that's even bigger, 3D printing process has limitations on size and quality. That's available to most makers and craft people. We can't all afford these humongous printers that you've seen on TV. You can't just go print a house. I can't do that in my backyard. It's not, well, I probably could, but not something I really want to do. Using brios and so on is probably not really all that good an idea. One of the things that you can get around that is, you know, using some other medium to do the mass production. And you could use the 3D printing basically to make molds. There's lost casting. I'm not really going to go into that there because I don't actually do it. Silicone molds, backforming, and injection molding. Injection molding, again, I don't do. Too expensive. But, you know, if for mass production, that's sort of where you want to go. And you can 3D print prototypes to do that, as we don't do. But I'm just going to show you what I'd actually do, which is silicone molds and backforming. So silicone molds, you know, if I want to make a whole lot of helmets, 3D printing it may take a long time, right? What I can do, and I don't really do this as much anymore, but I started off doing this, which was I would 3D print the helmet as a mold. So it wasn't completely usable. It was a solid thing. You couldn't put your head in it. I would then make a silicone mold from that, a negative of it, peel that back, and be able to then put casting resin into it. And then that casting resin would slosh around. You have a slush mold, what they call a slush mold, and you end up with a helmet. Right. So that's one of the things you could do. Don't do as much anymore, but there are a lot of people that do this. The other thing I've actually found that works really, really well is just vacuuming. So vacuuming or thermoforming, also known, is basically of putting a sheet of plastic, heating it up, and then sucking all the air out with a mold. I should have a video to show you how to do this, but I don't. But that's my vac former. It's not particularly big. It's basically a 500 by 500 meter sort of area. And I've actually got a piece of armor in there. And then the photo next to it is just what it looks like once you've sucked all the air out. So you put some plastic in there, heat the plastic up. It takes, depending on the type of plastic and the thickness, it can take like, 5-10 minutes to heat that plastic up. It becomes very flexible, suck the air out, and the mold is left underneath. Now, that sort of stuff that looks like talcum powder is, in fact, talcum powder. And that's to stop the plastic, because there's plastic on plastic. You don't want them to fuse together. So you basically coat your ABS puck in talcum powder, and you put it so it doesn't stick to the other ABS sheet that you've just heated up. So this is that armor which I was making for other people. I can make in different sizes. I basically use the 3D model and I can scale it to different sizes. So I'm using breastplate here because it's the one that changes a lot from woman to woman. We're all different sizes, right? For me, it's even, I have like different sizes of my own armor depending on where I'm at in my, my weight cycle. So you can see there, just that's all actually vac formed. And there's a couple of pieces which are actually 3D printed. Helmet's 3D printed. The knee thing's 3D printed, but the rest of it's vac formed. And we basically 3D print the mold. Gotta be careful. You can melt the mold, but it works really well. If you really want to do high temp, because we were talking about using carbon fiber before, you can put carbon fiber sheets in the vac former. It takes a lot longer, higher temperature. You will need to have you coat the or make a negative of the ABS vac form puck in probably something like fiberglass, which can take the heat. The fiberglass, otherwise the 3D print will just melt. So that's just one of the things you need to do. They're a bit used, but they've lasted. Okay, scanning. So how do you get like the original design apart from just sitting there in SketchUp or in Fusion, which is what I use? How do you put it all in there? Am I running out of time, Alex? Okay. All right, this is scanning. Really cool because you can make things different sizes.
Heaps of questions. Go for it.
Okay. The scanning is really cool. I was going to show you like just how cool. See, there's me. I was scanned. Isn't that cool? There's a 3D April. I'll just go. Okay. Space. I'll just quickly go over this. I've started with a space startup. I've used a lot of my original knowledge on creating props to actually create props for them, right? Because we're trying to get funding. So I'm printing, basically working models of turbo pumps and combustion chambers. And I'm using the same techniques I used to create props to create basically fake versions of rocket engines so that we can go into, and present in front of folk to say, look, this is our design for a single stage rocket to orbit. This is how it's going to work. And yeah, we've thought about the design. This is the conceptual design. And these are sort of some of the issues and problems that we've had with 3D printing it. The next stage is actually going and printing in metals. Now, it's been a huge learning curve for me. It's very exciting, just really started. The whole metal space is new and incredibly addictive. And it's really, to me, I think the next 10 years is where it's going to sort of progress it. A lot of inspirations come from people like SpaceX. That is actually a sort of early prototype of the rocket engine. You can see the turbo pumps and the main combustion engine. That is actually another couple of models that we had, and that's a 3D print with the internal honeycomb of the combustion chamber. That's it. I'll stop sharing.
Absolutely fantastic. Thank you, April. It's always such a pleasure and a joy to listen to you talk. And I know that, can I just tell you, the comments have just been popping off. Everyone's just like, that's amazing. That's incredible. And so impressive. We have probably time for just one quick question. And so I'll go with the top voted one. The printed parts you showed in your examples are beautiful. What are the typical post-processing processes that you have used for the parts that you've shown in your examples? I'm going to add a little shout out to you, because I know, April, that you're actually very humble in terms of the work that you do and the skill that you have, especially when it comes to post-processing. The post-processing that you do on these props is like an art form, right? So anyway, take it away. Yeah, please feel free to answer the question. It
depends on the material itself. Generally a sand. If most people print in PLA today, so if you want to get rid of the print lines, spray putty is something you can buy from super cheap auto, because it's to try and get scratches out of cars and stuff. That's probably where I start. You spray paint it, you then sand it back, because you can't really sand PLA directly because it tends to melt as you sand it. I also, use power tools as much as I can. This kind of thing. Actually, you know what? I got a YouTube channel. I will send you a link to some of my finishing techniques, because I can go on for hours on just how you can finish. So that what I can probably do is cut and paste the YouTube channel once I find it, and that'll probably help with that.
Yeah, thank you. I think that would be great. I think that you could just do a YouTube channel full time, right? With all of your 3D printing and props.
Doesn't pay the bills.
Doesn't pay the bills.
It needs to pay the bills. So unfortunately,
Nab would be very sad to lose you too as well.
Yeah.
It should be mentioned. April works full time in a job that is in the tech sector, but completely not 3D printing. She does all of this in her spare time, like outside of hours. So, yeah, super impressive, and thank you so much for sharing that all with us. April, all you need to do is just camera off, and then you'll hop off the stage. Okay. And it is time, so thank you again.